That's
Alors,
الكبير أوضح عشان كده أفك الصغير بعد شوي.
أنا نسيت النظام بتاعي.
Okay. Bismillah ar-Rahman ar-Rahim. Assalamu alaikum wa rahmatullahi ta'ala wa barakatuh. And a very good morning to all. Greetings to all our honorable attendees, staff and students. My name is Adila Muhammad Najib, Secretary General of Postgraduate Student Association PGSA 2020. And on behalf of PGSA KOE committees, I would extend a very warm welcome to all of you to this live interaction webinar on design of experiment. We appreciate you taking time off of your busy schedules and to join us today. We truly hope you find the program we have lined up for you to be fruitful and engaging. A great start to begin with this webinar is the recitation of Surah Al-Fatiha.
إياك نعبد وإياك نستعين اهدنا الصراط المستقيم صراط الذين أنعمت عليهم غير المغضوب عليهم ولا الضالين آمين آمين الحمد لله.
DOE, design of experiment, abbreviated by DOE, is a valuable statistical optimization method for screening from several parameters to obtain a smaller, reliable, and more manageable set of parameters in which all relevant factors are varied simultaneously. Approach is useful in improving the interpretation possibilities, reducing the number of experiments, reducing overall analysis time, as well as reducing the effort and expenses in case you are dealing with actual materials. So in this online interactive session, requested by many postgraduate students, we shall have your questions and concerns on how to conduct a successful DOE analysis answered by our guest, Prof.Dr. Nassereldeen Ahmed Kabbashi. I would like to also note that this session will be recorded for future pursuit. I also would like to get your attention. We will be having a Q&A session at the end of this session. Therefore, if you have any questions or concerns and you haven't filled the Google form in the registration, you may please drop them in the chat box and we'll answer as many as possible. I pleasantly invite the first speaker for this webinar. He is the current president of PGSA 2020 and a PhD student under the Department of Mechatronics Engineering, Brother Ahmed Rimas, to deliver his opening speech and insights. I apologize to all, but our president is not available at the moment. So we will proceed with the next part of this session. We are privileged to have him as our guest speaker today. He's a professor in Biotechnology Department, Kulliyyah of Engineering, IIUM, specialized in environmental engineering with 13 years of consultation, research, and guiding experience at the university, institutions, and non-governmental level and sector planning. Without further ado, it is my pleasure to invite Professor Dr. Nassereldeen Ahmed Kabbashi to deliver his instructions and remarks on how to conduct a DOE analysis.
Okay, بسم الله الرحمن الرحيم. السلام عليكم ورحمة الله تعالى وبركاته.
وعليكم السلام ورحمة الله وبركاته.
May Allah bless me and you and each and everyone in this session workshop today, where I have to have three tests, even though I know that there are some points that I cannot cover. But anyway, I promise, as I mentioned to the PGSA, if you need another session, and nowadays we are lucky at least that we are online. That means we can conduct it Saturday, Sunday, anytime suitable with you. Because the last part for 3D and analysis needs more time. I'm going to touch part of it today, but I'm quite sure that we cannot touch all the necessary point. In today's session, I'm going to explain about DOE. It's very, very important part for engineer, for technology, for what meant by design. Why is it very important? Why is it from this kind of experiments? What does it mean by design of space from the beginning? The student coming up for after undergraduate, we give him up in an undergraduate. Then he gets shocked on what to do. This is what I'm going to explain to each and everyone today. And like when you have to, and even there are so many questions that are important part. What does it mean by design of experiments? When I have to select design based on what factor, when I have to check that my selection is correct. What other amendments that I have to have? How could I understand that this things is working professionally or not working? All of those questions, inshallah, I'm going to answer for today for today's session. This session consists of 3 hours. I do have my best to record it into 3 hours, 1 hour each. First hour, I'm going to explain about the necessity for to have design. I think very important elements, how and when, etc. I'm going thinking directly. I hope that some of you has design expert software. Design expert software. I hope that some of you have, because we have it in all engineering labs. Even I told them that if you go to CSSU, they may give you this design experts. I have few licenses with me in my office. Later on, if PGSA come to me, I will give them some of them for free. So therefore, I'm going to link immediately, because I want a student to be updated. When I explain something, I will attach it with the software to show you how to link between those points immediately from the first time. This is what I'm going to explain in today's class. Please, if any student coming more, let me know, because when I start after that one, I don't know who coming in and out. So please let me know in case of any student coming at any moment. Okay, so now I'm going to explain the start of my class. I hope that each and everyone can see my window, which is shared well. Is it clear for all of you?
Yes, clear.
Yes, Doctor.
Clear. Okay, we start. I named the first part design of experiments made easy. How could we make this design experiments easy? Okay, why do a design experiment? This is the first question supposed to come to every student. Why do you have to design your experiments? What is important? This is a very, very important question that it needs an answer from each and every one. What is the importance of that one? So it is not a matter of job. It's a matter of fact. You have to have an idea what I want to have, or what I want to design an experiment. Along the way, again, in any manufacturing, lots of processes are governed or created by different variables that can affect overall the performance of the different processes. So therefore, it's very important or necessary to identify the critical process variables that for the purpose of controlling, for the purpose of smooth process, for the purpose of optimal operation of manufacturing, for the purpose of costing, all of those ones I have to have in my mind. Let me just go a little bit at the history of this design experiments. It started up 1980 up to 1940 by Fisher and his co-workers. This is a profile by factorial design and ANOVA. This is the first part, 1918 to 1940s. The first industrial era, 1950 up to late 1970s, Boxer Wilson. Second industrial era, late Takushi, Robust, and etc. So now organization is driving all sectors of the economy to be more competitive. Competition now is very high. Competition now, long time ago, we look at the point from our own side of manufacturing, what resources we have. Nowadays, no. We look after the customer needs and wants. What the customer needs and wants. That means competition. You have to serve the customer. Not the customer select whatever you have. So, what the designer, the engineers learn about design experiments. All of you engineer here. So, what we need you to understand, what we want you to grab, what we want you to have at the end of the day. This is a question. That is number one. DOE is a powerful statistical to better understand them and they can be optimized. Optimization your resource. Optimization your factors, optimization, your product. All of this is very, very important. This matter is very complex, but we have to optimize it. Number two, understanding any field of engineering system require multi-dimensional understanding of factors and factor interaction and their influence on key output. And this is what I repeatedly say even to our undergraduate students. We are talking about interactions. If you'd like to produce anything, consists of so many interactions working together. So those interactions, you have to know about them in detail. So which one is the most important one? Which one is supposed to take care of fully? Which one is supposed to work with you in the proper way? Or this is what we mean by interaction part. So in today's class also we are going to explain about that one in detail. The third important part, acquiring enhanced knowledge and capability enables quality improvement. I'll talk about whenever we say engineering, that means we'll talk about quality. What allow me to come and buy, for example, your material? I have to look after the quality. If you don't have a quality, nothing allow me to come to you. Am I right? So therefore, quality is very, very important aspects. I have to look at it carefully. Number two, increase productivity. To increase my production. That means I have to go for better design of experiments. If I don't have good design of experiments, that means I will be in trouble. Therefore, this is another important element. Third one, resources saving and more. Most important thing. How could I save? I control my resources. Those are the three important elements that we need to have for this DOE. What is field the class? At least you plan in advance. This is what PGSA did with you a long time ago. On this day, 22 October, 10 o'clock, we are going to have workshop. That means plan. Number one, complete plan. Complete and analyze using statistical consideration to increase efficiency. Efficiency of the work. Secondly, design of experiments has a rich history connected to agriculture, to engineering, to manufacturing. That means what? That means it is already there. Therefore, we can enhance it, we can develop it, we can gain more experience from it, rather than to start something from scratch. That means we already know about it. Classic design experiments attempt to attain all experiments into a handful of well-known, often inflexible, and in certain type of designs. Number four, modern statistics software packages allow non-experts to create flexible but sensible designs based on their own needs. And this is the most important part. Even though you don't know, you are not experienced enough, but the software now allow you to be experienced and to use your own needs and wants from this design experience. Okay, now we say design experience. Then what is experience itself? Experience is a test or series of tests where the experimenter, you, makes purposeful changes to input variables of a process or system so that observe or identify the reason for changes in the output responses. I'm going to give you an example right now. That means a test or series of tests for you as a tester for a certain amount of changes in input to see what is your output response. Design of experiments is concerned with the planning and conduct of experiments to analyze the resulting data so that we obtain valid and objective conclusion. Valid actual value that you are working with. We are working with it right now. Type of experiments have different type of this experiments. Two important part, discovery. I would like to discover something new. As of design to generate new idea or approaches. Now, please all of you now put in your mind, what is your title? What is your problem statement? What are your objectives? Immediately you can answer, you can find yourself in which part you are here. Are you going to design to generate new idea or approach? Are you going to involve hands-on activities? Many involve system or processes that are not well understood or defined. So this is what I would like to do from the first part, discovery. Secondly, of a certain type of hypothesis. That means closer traditional academic approach, or seek to falsify a specific hypothesis, used often in the attempt to prove the theory, idea, or approach, or to develop any of those ideas or theory or approach. So why experiments? Why want to go for experiments? Experiments, that means I would like to determine which variables are the most influential in a process or system. This is part of your study. Why you would like to go for experiments? Determine where to set the input so that the output is always near the desired state. That means what type of input I have to put together to have an output. And English, they have a saying, garbage in, garbage out. That means if you put garbage in, your result will be garbage as well. This is what I mean by that. So therefore, you have to be very careful about selecting your input to have a good output. Determine where to set the input so that output variability is minimized. Would like to minimize the output variability. If I do that one, if I succeed in that one, then I succeed a lot. Right? The fourth one, what I have to do, that is determine which part of the experiments, where to set the input so the output variability is minimized. Determine where to set the input so that influence of uncontrolled is minimized. Let me now, with all of you, look at me at this diagram that I put, very simple diagram. I have certain type of factors here. Then I come to a process. From this process, I have my output. Let me put it in a simple way. I would like to increase the understanding of factors and interactions. This understanding of factors and interactions. Then I put it into certain process. What is the output? The goal is to optimize and ensure sustainable solution. Sustainable solution. Sustainability. Now we'll talk about sustainability in everything. Not just produce some. No. You can give you an example. My V car. My V car. My V car. Who knows about it? Now it is almost everywhere at the road. I name it 1 second car at the road. Every second you may see my V car in front of your eyes. Why that one? Because sustainability has been sustained. Everyone can use it. Student, businessmen, women, boys, girls. Why? Because it's excellent. Okay? Let me just for this one. If I would like to make perfect boiled egg, all of you now think with me. You would like to boil egg. You would like to boil an egg. What are the factors that you need to boil egg? Number one, water temperature. Am I right? You cannot just put water in normal water and you say that one my egg has been boiled, or you can eat the egg. Impossible. You cannot work. This is what it meant by factors. Number one, water temperature. You have to increase water temperature. Number two, exercise. Exercise is very important because also it takes part when you would like to boil. Number three, length of cooking time. Length of cooking, how much time? Some people would like to make it well cooked. Another people, they would like to make it partially cooked. That means the yolk inside, they want to have it moist, and so on and so forth. So therefore, those are the factors, input factors. This is the process that you put in a container, etc. Container, what is the output? How do you realize that your egg has been boiled? Number one, I look at your viscosity. That is what I say here, exercise, water temperature, and time. Those three factors interact together to give you your viscosity. Number two, how could I realize also my output is well boiled? I look at the firmness of the egg white. Firmness. If it is firm enough, that means, now my egg is open. If not, that means something going wrong. This is a very simple example of what we actually did in our daily life, but we never pay attention to it. Same thing goes to if I want to, many people here, they drink tea opanas. Tea opanas, hot tea. What are the factors that you need? Water, tea bag, amount of sugar. How could you know it? You look at also after yield about hot or cold of the tea. This how could you realize that yourself cooked or is what input and the out. Okay, so now for engineering field, many of you, I just give very simple example here from chemical engineering study, that if I have to have certain amount, you may have certain amount of temperature, certain amount of catalyst, certain amount of sizing rate from 2. Then you have a process. So what will happen at the end of the day to get those 3 factors working together, I look after the yield. Is there any corrosion resistance? Is there any impurity? I look at the cost. Look here, those are the input, those are the output together with the process. So this is what did we do in our daily life. And now each and everyone now, immediately, please with me, and by the way, I can open my channel, any student who would like to look after his design experiments. Later on, you may contact me personally, show me your factor, your design experience. I will help you as much as I can. I'm very welcome for all of that. So therefore, look after your factor input. Look at what type of process you wanna do. Batch process, continuous process, continuous process. What are your outputs for the function f of x? What output you would like to have? So this is the meaning of that. Now, why is DOE very useful? Number one, improving lab efficiency, experimental improving lab efficiency. I want to use as I can from the lab. Number two, improving experimental design. Rather than to waste my time to stay at the lab for conducting 24 experiments, why not make it for 16 or 17 experiments only? Save my time, save my energy, my delivery of quality, deliver proper, reproducible solution. I would like to reproduce whatever people did other part of the world. So therefore, quality very important. Purpose, reproduce. This is another very, very important part. Number 4, for chemical engineering, as an example, improving a process, improving a yield, improving whatever. You can do the same thing for mechatronics, for civil engineering, for manufacturing, for material, and improve whatever you have in your hand. Number 5, understanding and investigating interaction in complex systems. And this is the most important part, let me tell you for now. This is the most important one. That is understanding and investigating interactions. As I showed you right now in this boiled egg. If there is no interaction here between water temperature, X size, and length, I will not have this output. So this is what I mean by interaction. That one, to have this interaction, then I would like to have all of those 5 elements to reduce frustration. Reduce any frustration that I may have during my conducting experience for my master or for my PhD, whatever. Okay, what are the factors? What are the output? Whatever you say about factors could be fairness temperature, could be type of coating. Output, as a result, what one could be corrosion, could be corrosion resistant, maybe. If I have, for example, temperature, time, catalyst, proportion of mixture, then you talk about yield. If I talk about temperature, about still rate, and you talk about yield and purity. So therefore, this is almost put your factors here. What is your factor? Then you can imagine what is my output supposed to look like. This one, initial part, each and every student must do. If you succeed in that one, then make sure that you are at the right track. Okay, there are 3 R's of DOE. 3 R's. What are those 3 R's? Randomization, replication, and repetition. Randomization. Because long time ago, I would like to direct my experience towards what I think or what I believe. That means you're forcing your result according to your need, not according to the reality. This is what I mean by randomization. Randomization, that means sequence of experiments or assignments of specimen to very strict combination in a purely chance manner. That means without affecting from your side or from anyone. To allow this result to come outside randomization. Number two, replication. If first 2 or more runs were conducted under the same test condition, each run following a new setup or a resetting of the conditions. This is why we ask the student when he comes to the Bible, how many replication? 2 or 3, the higher the better. I'm going to put that one in short when I start to give you for design experts. I'm going to show you how you make your replication. Repetition, obtaining more than one measurement or units of output for each run. Very, very important. Obtain more than one measurement or unit of output for each run. Therefore, if those 3 values are there, that means your design experience is going at the right track. Okay, there are certain type of checklists each and every one student must have. What are the checklists for planning? I say the most important part is the planning experiments. Number 1, you have to obtain a clear statement of the problem. Now I come with all of you now. You have your title. This is why normally when I go Viper or with any students, I look at the following. Number 1, I look at your title. Then I look at your problem statement, your objective, your methodology, your result. But I concentrate more at your title and your problem statement. Are they linked together? Or you write a title in such a way that there is no relation between your title and your problem statements. So please be aware of this one from the beginning. When we tell students that why we ask you to come to comprehensive exam would not to create for a student trouble. No, we want to help the student from the beginning. We want to put him at the right track by to have clear statement of problem statement, by clear amount of background of information, literature review, methodology. This is why we ask the student to come for experimental design. Therefore, a clear statement of the problem it means that you have to identify the problem area in quantity. We are engineering quantitative and qualitative. Quantitative. How much temperature? When you say temperature, between what to, from what to what? 50 to 70, pH 6.7 to 9, sizing rate. Between what and what? Concentration. At what? Between what? And so on. So this one is quantitative term. Number 2, identify the response. Response, that means your output to be measured. The factors that may vary, the factors to be held constant, and the factors that cannot be controlled. All of those one you have to put in front of your eyes. Therefore, you'll be in safe. Identify the ranges or limitation of the measurements and of the experimental factors. What are your limitations? Things you can do, things you cannot do. Then you have to mention all of that one from the beginning. If you succeed in stage number 1 for obtaining clear statement of your problem, then you collect your available background information, literature review. Investigate all available sources of information. Investigate. This is why we also look back at the past 10, 20 years. Some students only past 10 years. No, for my PhD student, I ask them, no, after the past 20 years, what are those people doing? Collect the suitable information that related to your study. You are not the only one in the world who did this one. Why this one very important? Because you can find out the gap. This is why I insist in all students at the end of your literature review, make title, name it research gap. After you collect the information, what gap you find between past 20 years and up to now? Let me give you a very simple example. Past 20 years, we don't have this mobile data now we have in our hand. That means the gap is very big, clear in front of everyone hand. You can see. In the past 5 years, we don't have online. Zoom, now on Zoom come in the middle, Google Meet, WebEx, all of this one. Gap was not there. Therefore, people start to invent it and come out with new idea. Don't think those things coming but from nothing. No, it come after what those people, they monitor what happened for the past information. Number two, tabulate the pertinent to planning the experimental program. Tabulate them. Put the past 5 years for this part. What did those people do? Then another 5 years, what those people do. Then you have a very clear picture about information that you have in your hand. Then most important thing for Kuliyyah of Engineering, I always advise my students, be quantitative. Don't tell me qualitative. Don't tell me that the experiment is good or the result is excellent. What do you mean by excellent and good? We are not in faculty of art. We are not in pseudo-Romeans, that means beautiful art or beautiful song. It cannot work here. For engineering, you want to tell me quantitatively. Quantitative. If I use, for example, this amount of fuel with the car, that means it will take me this kilometer. This is what I want to find out from you. If I put this amount of sugar with this amount of salt, with this amount of etc., give me certain amount of fuel. I want to find out quantitative, right? What other thing would like to have? Design the experimental program. All the parties concerned. That means you state the proposition to be explored. What are your proposition or problem that you would like to address? Agree on magnitude of differences and response considered. Outline possible alternative outcome. This one you have to discuss with your committee. This is why in comprehensive exam, when you come, the examiner asks you about those questions. What are the other alternatives? Choose the factor to be studied. Determine practical range of factor. Very important for the practical range. Temperature between 50 to 70. pH 7 to 9. Normally I ask my students, avoid the severe pH 1 to 2, 13 to 14. Try to avoid it as much as you can. Choose the measurement and method of measurement. Here you have to double check at your lab. Do I have those type of sensor or method of measurement? If not, then you change your idea. Because at the end of the day, I have to use according to what do I in my hand. Consider the effect of variability and precision of the measurement. This one, it is a lot of time to explain. But I'm going to short it in variability of precision. Precision coming from one place to another place is going, there is a certain amount of differences. As of, for example, Southeast Asian amount, different from Europe amount because of the environment, because of whatsoever things that people they do. Consider possible interrelationship of the factor. That means the connection, interconnection between them. Determine the flows of time in each and every one. Please put in your mind what type of time, cost, material, manpower, instrumentation, and facilities, and of extra nonsense such as weather. This is what I explained to you right now. Southeast Asia weather, different from Europe, different from Africa, different from whatever countries. That's why yesterday I asked my student and for engineering management, if I ask you right now, go and take commercial car, send it to Gulf country, and I select, for example, Saudi Arabia, as an example, or Kuwait. Send this car to Kuwait. Is this car can be workable over there? If you have been appointed as consultant, can it work? I will ask this one. I will open now for question. May I ask Hamida Hassan? Hamida Hassan, are you here? Mr. Hamida. Okay, brother Bari Saad. Bari Dad, are you available? Salfarina Rosman. Okay, if all of you, I know this system. Radia, Mr. Radia, can you open your mic? Oh, where on? Anyone can answer? If, for example, now I ask you to select this car to send it to Saudi Arabia. Can she car in specific? Brother Mir Akram? Mir Akram?
Yes, I can hear.
Yeah, say whatever. Yeah, say whatever, brother. If I have been asked now to take this commercial car to send it to Saudi Arabia or to Kuwait, for example, and you have been appointed as consultant, can it work? Engineer, don't get shy. Say whatever you have in your mind. We are here because you don't know. Then we want to help you to know. That's all. So no one get shy from whatever it is. Yeah, Brother Ahmed.
Yeah, bro. Alhamdulillah, I'm trying. Just stop my car. I think it is not working because of temperature. In Asia region, they are
At one point,
humidity. Because of temperature in the Gulf region is about above 50 in the dry season. That is a problem.
Yeah, it reached up to 65 degrees Celsius in Kuwait.
Yes.
From May up to June, mid of July, it reached up to 65 degrees Celsius. You can imagine.
Yes.
You know what I'm talking about. Thank you, Brother Ahmed. The point that I need each and every engineer to think about. Think from big side of picture. This is what I explained to you right now. Look at the time. Cost of fuel in Gulf country is more cheap than the cost of water. You know, the roads are extremely big. The size of the people over there quite different from the size of people in Southeast Asia. That means by default this car cannot work over there. So this is what do I mean by experimental design. I would like to design to certain type of people. Same thing goes to, now I would like to look carefully here in Southeast Asia in general. You will not find material as of white telephone cover or white color car. You cannot find easily. Yes, there is some, but not many. Why? Because same thing goes to the weather. The weather cannot help you. If you put your car right now outside there, due to humidity, the rain, the sun, in very short time you will find your car white car color. It looks mess. Why in Middle East country in Africa they prefer white car? Because the weather is very hot. Look in general here how the people dress. You dress here colorful. In Europe they dress what? Black color to absorb heat. African Arab countries they put dressing on white color. Why? Because they don't want to have what heat. The weather already very hot. So like to avoid hot weather. Hot weather can avoid it by white and so on so forth. This is what do I mean by you have to determine the whole influential of other factors before you start to do your job. Then you have to consider a personal and human relationship requirement of the program. Some student, he can do a job, very hardworking, he can do this task. Most of the time you'll find him at the lab. Some student, no, he's different. He cannot do his job most of the time of the lab. So he knows his capability. Design also in the elementary form, prepare systematic and inclusive schedule, which includes randomization pattern, provide for stepwise performance or adaptation of schedule if necessary, eliminate effective variables not under study by controlling, by balancing, or by randomization. Yes, variables are there, but it will not affect too much in my work. Yes, I'm not going to eliminate it from the process. It is there, but it has no major effect. Minimize the number of experimental runs consistent with the objective. Right? Minimize as well. Minimize, choose the method of statistical analysis. Arrange the orderly accumulation of data. Review the experimental design program with all concerned, with your supervisor, with your colleague, with whomever has experience, because this is the core of your work. If you fail this one during your Viva, you can imagine that suddenly the examiner tell you whatever you do, your experimental design is incorrect. That means 3 years already gone. Right? Adjust the program as required. Spell out the steps to be followed and mistake. Then the other important part, interpret the result, consider all of the observed data, confine initial conclusion. Yeah, because I have initial conclusion, what I want to achieve. When I have my data now, I have very strict with the document from the experimental evidence that I have in my hand. Elucidate the analysis in both graphical and numerical terms. State. This is why I always advise my students, try to put your result into graphical term. It's more clear than where the right result in terms of verifiable probabilities. That means from to arrive at conclusion as to technical meaning of results as well as their statistical significance, supposed to be correlated to your analysis and your data and your statement. Point out implication of findings for application and for further work. Very, very important. What do you advise for your further work? It's on the conclusion and result. When many students that after I go to his comprehensive exam of his thesis, he never put anything for his further work because another student may come start up from your point. Account for any limitations imposed by the or by the method of analysis used. Then you have to put that one in your place. Last thing, prepare the report. Describe work clearly, giving background, pertinence of problems, meaning of the results. Yeah, many students have a very good data, but when he come to interpret, he cannot understand. He doesn't know how to interpret his result. What do I mean by interpret? That result you have, is it in line with your objective, with your title, with the sustainability, with the finding to human being? All of those points you have to have in your value. Don't tell me that I have this value 60% here, 20% here, 40%. So what? Use the tabular and graphic methods of presenting data and consider their possible future use. Very important. Supply sufficient information to permit readers to verify results and to draw their own conclusion. The moment you give me sufficient information, for me as a reader, I know what conclusion that you would like to address. Therefore, that means you did a very good job from the beginning. Limit conclusion to objective summaries. Yeah, because from the summary of your result, I know what did you do for all of your work. Those are the prepared for your report. Okay, let me now just take. We'll come back again. This is a DOE example. I'll give you an example. All of what I explain right now, I'm going to put it here. Let me give you here. I have certain type of factors. Factors. Whenever we say factors, that means talk about variable input. Factors, look at this word very carefully. I have factors, that means I'm talking about variable input. As of oven, or sugar, or flour, or egg. This is what do I mean by factors. So we look at them very carefully at those factors. What I want to achieve from these factors, as you can see here, those are the input value. Oven, sugar, how much amount of sugar, how much amount of flour, how much amount of egg. Level, setting, that means the temperature. Do not and what sugar, how many cup, or gram, or milliliter, or whatever. Egg, number, 2, 3, 4. Why all of this one? This is the factor, this is the level. What I want to have, the one of egg. The outcome. Here, response that means I'm talking about outcome characteristic. Again, go with me. Factors, input, level from response, that means the outcome characteristic. For example, of characteristic. Some people may look only after taste, tell you, oh, taste is excellent. Quantitative and qualitative at the same time. Some of the people look at the color. Some of the people look at that consistency. Some of the people tell you, I don't like to have sugary. That means what? Doesn't want to have sugary. Then from the beginning, they tell you this one for non-sugary people or less sugar. Or some people, it doesn't want to have, for example, more egg, would like to look after cholesterol in his body. And so on. So those ones are the response. This is why you'll find here a code. Now, not all things, I may change in all of the output. If I want to make the taste good, or color good, or consistency. Therefore, I may change it. This why here output different from one place to another place. Those are what is meant by part. Let me give you those factors now. The level, the response. Let me explain to them. This is what you are going to see right now from your known as DOE vocabulary. Factors, that means, are those quantities that affect the outcome of experience input. Those are the factors. K, number of factors or variables, the effect of which are to be estimated in the experiments. Number of factors, how many number of K? 3 factors, 4 factors, as you can see from here. 1, 2, 3, 4, those are the K. Right? Level, values that factor will take in experience. This is the level. Here. Temperature, 60, 70, 2 cup, 3 cup, 3 egg, 4 egg, etc. This is the level. Run, the of operating the process with the factors at certain setting. This is the number of run. Right? Then, after that one, I come to talk about another important part, the treatment. Whenever you say that means the combination of all the levels or factor for a given test or run. Then I come to response. As you can see here, this is the response output characteristic. Output characteristic. Still, I have some more that you may find. You may have experimental error, the amount of variability that may be expected in the experiments environment, just by chance without any change of factor investigate. I'm going to show it to you when we give you a real result. Effect. What effect? Let me go back here. If, for example, here I'm look after test, what are the main effect here? You can see here according to this one. For the factor, what are the main effect? Sugar, am I right? You talk about the taste. You talk about the color. That means you are talk about the egg color. You talk about consistency. I'm talking about the flow. And so on. So what is by main effect? To have this, there is some of those factors together. Oven, sugar, flour, and egg. They interact together to give you the cake at the end of the day. This is what's meant by interaction. And this is very, very important. The greater the difference is flow between the higher the degree of interaction. I'm going to use that one in more detail when we start to analyze the system. MSFE, minimum significant factor effect, is the minimum absolute value of an effect which may be considered a significant result. That is significant result that I obtained from this case. What are the minimum significant factors? That means which factor that on the process. Factorial experiments. That means now designed to determine the effect of all possible combination across all level of factors that are studied. Fractional, factorial, designed to determine factors with the fraction of runs required for a full factorial. That means how to minimize them. I'm going to explain to them after a while in more detail. Another important elements that you will find for DOE, any DOE, confounding. That means the consequence of conducting a fractional factorial design. I'm going to talk about it after a while. Blocking, this one very, very important. Blocking, that means technique used to increase the precision of experiments by breaking experiments into homogeneous segments in order to control any potential block to block variability. That means whenever you set up your experiments, they tell you block number 1, block number 2, block number 3. What does it mean? That means they select certain amount of experiments according to whatever their precision, put them into that type of blocking. That means the quality of a process or output being little affected by environmental or internal component variation. Noise, referred to variability, no analysis of variance. That means they come for the testing. That one I'm going to talk about it in more detail. Any question? Any question?
Sir, question last.
Question now, 11 o'clock. I give you 5 minutes only. Okay, then we may have 5 minutes break. Exactly 11:05, I will start again. If that one okay with you. Okay, then we have 5 minutes break.
السلام عليكم.
وعليكم السلام ورحمه الله وبركاته.
الصوت كويس عندك مني؟ سامعني كويس؟
سامع كويس جدا.
لانه كان بيتقطع مرات في اثناء البرزنتيشن، فده كان يجي ويقطع مره كده كلمه كلمتين. في زول عامل كنترول غيرك؟
لا سامع كويس جدا يا واسع، صوتك واضح.
صوتك انت جيبيه لما تعمل برزنتيشن مره كلمه كده تروح كلمه تجي. ما اعرف مني انا ولا من
والله ما اعرف كده
مثلا الباقيين لانه
انتبهنا. ايوه لو كان في تقطيع من بروف كباشي.
نعم
كان في كلمات فعلا بتتقطع من بروف كباشي.
بتتقطع برضه صح؟ انا برضه بالنسبه لي انا افتكرت في جهازي بس الكعب.
لا والله ما اعرف كده معناه في مشكله يكون في هون ما عندي بشكل عام في مشكله في النت. اسال السكن اللي قاعدين فيه الناس كلها بتشتكي من النت،
تكون حاجه عامه معناتها. يلا خير ان شاء الله. خير.
Anyway, I hope that the second part is okay.
ان شاء الله it'll be okay.
ان شاء الله.
One question has received in the chat box is, Assalamu alaikum, Prof. What if your research is on designing device? May you please give the example of the factors, level, responses?
No questions coming from anyone?
Sir, Assalamu alaikum, Prof. What if your research is on designing device? May you please give the example of the factors, levels, and responses?
Yeah, that one is in the second part. I'm going to do that one in detail, inshallah. That one I'm going to give it, inshallah, right now when we come back.
I have a question for the. Are you going to give us like an example later on directly in the design expert to see how we read the
yeah, definitely.
And everything?
Yeah.
Okay, thank you.
What I'm going to give in the second and third part, I'm going to give how to build up, because there are different types of experimental design. The second part, I'm going to show you all the type of experimental design. What are they? Number two, I'm going to give example for each. I'm going to give of analysis, how to analyze the result with ANOVA, with three-dimensional factors, whatever it is. This is what we have to do. we may not complete all of them, but what we do if we cannot have another session only for analysis, because analysis is the most analysis and interpretation of your result. So the most important part for each and every student must know. Okay. So now in another 1 minute I will come back.
Sir, how to know the suitable factors to be used for our research?
Come again?
How to know the suitable factors to be used for our research?
Yeah, that one, this is what I say from the beginning. It depends on your literature review and your objective. What is the most important part that you would like to study? Because you cannot study everything. This is why I say from the beginning, this is why you ask students for comprehensive exam and to show us his problem statement and his objective. And normally we tell students, now your objective is to be between 3 years or 2 years. My objective.
So how to choose the right design?
Yeah, this is what I'm going to explain now. You just pay me your attention. The second part, I'm going to explain this one now.
Okay, sir.
Okay. Okay. Now I'm going to make another record for the second part. The first report. So I'm going back. Now I'm going to talk about the second part. Okay, I'm going to talk about the strategies for the designing your experiments. What is strategy that you have to have when you would like to design your experiments? There are 3 important elements for each and every experimental design. Number 1 is startup, look from down there up to up. Start up from screening. Screening up to end up at optimization. Screening, that means it is highly fractionalized factorial. Many potentially important variable, that means you are going to study here. If your study is potentially important, you like to test which variable, then I go for screening. Meaning to say, I would like from 50, would like to see the most important bacteria that affect in my study. Let's get a proper way that we may face right now. Now we have the dilemma of this epidemic of pandemic of coronavirus. But it is a virus only, just like chicken virus, like any virus. What exactly what virus is this? This is why the whole scholar worldwide, they do a lot of tests worldwide. Up to this moment, they don't know exactly which test is there. To do all of this one, they go for what is known as screening. Screening process to find out which one this virus is the main in your body. This is why up to this one we couldn't do. So screening, that means we are going to look after to fractionalize the factorial, the factorials. We look after few tests to find out what one is the most important variable that we like to study. If I succeed in that one, then I may go to the second part, knowledge building stage. Here I look after full or high resolution fractional factorial. few important variable. I'm going to merge it. That means here I reach at the constant value. I'm going to show you in short. Knowledge building. Third one, optimization. This is a high level. Here I'm going to replicate my design. I look after full factorial. I look after evolutionary operation, response versus methodology. Here, base settings are determined. Let me explain this one into this diagram. Look at this diagram. This is the strategy. Here, the screening process is come down from here. Go back to screen. Then this is the region of my factorial, fractional, and factorial experience to get close to the peak. Not yet come to the peak, but I'm moving to. This is what I do. I mean by knowledge of building the state. Right? So the third one, response to surface modeling to climb up. This is a path. This is what I would like to optimize at the end. So this is the strategy of your experimentation. You start up from screening, then you jump up to near peak, whereby here you test your knowledge building. Then you come to response methodology for optimization. This is the region of your interest. Therefore, I'm expecting each and every student now supposed to understand what is the region of your interest. Meaning to say, are you going to look after the speed of my vehicle? This is when your interest. Is your interest, for example, to minimize, to maximize production line? Is your study to minimize the pollution? Is your study to minimize whatever or maximize? Minimize and maximize, both of them are optimization, but from different side of view. Okay, now design experiments. A good experiment must have the following: avoid systematic error, supposed to be precise, supposed to allow estimation of error, supposed to have broad validity. This is why we have it in such a way like that. All of these ones are there, and from here we have, for example, if you have here the product, trade, and mission. Then I know this one I put into those red color. Those are the range of interaction of my result. Those are the optimum value that from my result. Right? Now, design experience, comparative experience estimating different response. Right? For example, if response for unit receiving a treatment, 1 are measured with instrument A, and response of treatment 2 are measured with instrument B. Then we don't know if any observed differences are due to treatment effect or instrument miscalibrations. Because you tested with instrument A, but other person, maybe in America and Europe, they use an instrument B, more advanced. Maybe it's one miscalibration, give me the error. So this is why we go for randomization, is our main tool to combat system error. This is the thing behind why we go for randomization. Design steps here, number 1, select of factors, levels, and ranges is the question coming out from the system. Select experiment design, performance of experiments, statistical analysis of data, conclusion 1, 2, 3, 4, 5, summarize all of those selection factors of level of your range. Selection of response variables, your output. Choice of experimental design, I'm going to explain it in short. Performance of experiment, we are going to perform experiment. Continuous, in batch, in semi-batch. Statistical analysis of your data. Which one you are going to conduct? ANOVA, P-test, T-test, two-way ANOVA, one-way ANOVA, etc. The conclusion and recommendation based on your statistical analysis. So, therefore, use team's non-statistical knowledge of the problem. You have to choose the factor, determine proper level, decide. This is the same. Now, just as I said. Now, this I put all this one into this diagram now. After I define my problem, sisters and brothers, what is my problem? Together here, I have my title at the top. Then I define my problems. I define my objective. I be precise. I have to make brainstorming with my committee, with my classmate, with whomever, to double check step number 2 and step number 1 is correct. If after look, I go for objective, to design. No, I make to do storming with your committee. I repeat, not with individual person, with your committee. Because a lot of problems at the end of the day will arise due to someone, it just depends on only one supervisor, which is incorrect. You have to have a committee. Committee that is all well together. Then design for your experiments now. Then conduct experiments, collecting data. I conduct this, I have to collect data now. Then I have to analyze your data. The big difference between analyze data and interpret result. Analyze data, that means give me the R square, give me B square, give me lack of fit, give me all of that. This is the analysis of data. But you have to know how to interpret your result. Then verify the predicted result by doing the experiments again. They will check all of this one is correct. Those are the 8 steps for each and every one. I repeat again, because this is the core of our course. You have to define your problem together with them. You have to understand from the problem, how could I define my problem? How do I have my objective? After I study very carefully to literature review, then I come out with the objective. Then I make my brainstorming with my committee. Then design my experiments. I'm going to show you this one I'm going to explain now. Then conduct experiments. If you study in this one, the rest is easy. Conduct your experiment, you collect your data. You analyze the data, you interpret your result, then you verify and predict the result. So in general, several factors or main factors will be significant. Must be. Some 2 factors, interaction will be significant as well. Very few, if any, 3 factors and higher order interaction will be significant. As of what, let me go back to the cake that we make initially, explain initially. We may have 2 important factors to have good cake: the sugar and the color of the cake. Some people look at the sugar and the color. To have the 3 of them or all of them into one factor sometimes is difficult. That's why I have as much as I can. Number 1, the first factor is supposed to be significant. Significant, that means absolutely is correct. 2-factor interaction is supposed to be significant. Very few, if any, 3 factors and higher order interaction will be significant. This one here, chance of being significant. The factor here is significant. 2 factors, look here, is significant. 3 factors, significant level is less. This one, the kind of concentrate on benefit of 2-factor interaction. However, in a 3-factor interaction is received, then include in your experiments. This, what do I mean by that? If any of you who succeed up to 2-factor experimental methodology, best guess that the pros and cons. The pro, when reasonably when used interact with solid functionality. Not true. Cons, if you help, need to guess again and again and again and again. If get acceptable results first time, will stop without discovering the better. And this is the dangerous. This is what do I have best guess. This is what people do long time ago. And I'm not prepared to have best guess. Second one, type of DOE, design experiments. 1 factorial, full factorial, fraction factorial. Screening experiments consists of 2 parts: bracket Borman design, Takeuchi ordinal array, it's known as Takeuchi OA. Takeuchi OA. Response surface methodology. This one for optimization. Look here now for the sister who asked me right now. Consideration is selecting your experimental design. If I'm talking about screening only, then you go for fractional factorial, or you go for resolution for fractional factorial, or you go for bracket Borman, or you go for Takeuchi. If we talk about modeling, look after full factorial, or look after resolution V factorial. fractional factorial or central composite design banking. To talk about optimization, you are looking after response surface methodology. Let me now give it this one into what you can see here. Now I'm going to, now I guess everyone you can see with me here. This is design experts software that we use. The startup, we have different values, different issues here: file, edit, view, display option, design tool, and it comes to you in such a way like that. Welcome to design experts. It comes by state ease. Then we go for new design, or go to file, new design, either from here or there. If I say new, look what happened to you. It opens to you like that. You look carefully here. What do I have? I have 4 factors here, or 4 issues. Factorial. We say here minimum response, V, 4, irregular factor, general factorial, optimal, Blackett-Borman, Kabbashi. This one I can use according to what I explain right now here. Say what? Screening, resolution 3, or resolution 4, or Blackett-Borman, or Kabbashi. This is what I use for screening. If your work is on screening only, as we have again here, this is all for factorial. That means your work is supposed to be in factorial.
Excuse me, sir. This
If
is
it is not factorial, it's not on this.
Sir, this is a software.
That is software.
Oh, okay. So it's an open source or paid? Is it open
Come
source?
again?
Is it open source software or paid software?
Paid software.
Is it free?
They can give everyone 1 month for free. Yeah, 1 month for free.
Okay.
They can give 1 month. If you go around state ease, then you can download it right now. Any of you can download it right now. Now I guess even they have version 9 or version 10, I'm not sure. You will have it. Then you can download it, can use it. In our Kulliyyah, we have it. If you go to CSSU, if I'm not mistaken, I can give it to you. If you come to me, because I have 6 version, long time ago, I can give it to you again. The 6, the old version. But still it can work. Any of you. It is not pirated, it's original software.
Okay.
Yeah. So please, as much as you can try to avoid pirated one. Try to go for a real one. And I guess they have a special promotion as well for a student. And by the way, it's not important to use only design experts. You may use Minicap. You can use stat graphics. You can use something like GMP. Those are the type of software. GMP is the recent one, even the most advanced than all of the GMP software. I was attending one workshop recently. It's very good, especially for interactions. We show you exactly which one interact, at what level, what you have to, and so on and so forth. But in general, this is the one that we have in our Kulliyyah of Engineering. In all our lab, you'll find it over there. General purpose lab, you will have it. The lab above Musalla, you will have it as well. In E5 lab, in E5 computer lab, we have it as well. So you may come and use it. So this is the first one that we use for screening. Okay. If I come to second part, for modeling, I'm going to use full factorial, resolution 5, central composite, and box banking. Also, we can use it from here. This one here, resolution 5. You can use this one for modeling. You can use here for this one, other response surface methodology. Box banking, you can use from here. This one for what? For modeling. If you work only concentrate about modeling. Central composite, as you can see it here. Here, central composite design. Box banking. Substances, response surface, give you central composite design. Right? Or you may, if your interest is optimization, you can go for response surface methodology. Response surface RSM is known as RSM. Here, response surface methodology. Here we say central composite. Central composite is the one that you would like to use, for example, for modeling. Box banking you can use for modeling, That one, any of those, that one can be used for optimization. Right? To proceed, I'm going to give you some example on that one, real example in short. Those are the factors. So please, everyone now, please imagine your work. What is your work? Is it on screening only? Then take notes. By the way, I'm going to leave a copy of this one with the PGSA. You can take it later on from them. The soft copy of presentation today. Conductor PGSA will pass it to all of you. Modeling, if you work only on modeling, you have to look after full factorial, resolution V, fractional factorial, central composite, or box banking. If you work on optimization, then you have to carefully look after RSM. Those are the of consideration in your experimental design. You in a very clear picture. Do you need for DOE to be identified? This is the first question you have to ask. Yes, I need. Then define your problem and objective. Never define them, you will not have this one. Then I define them. Then define the matrices for response value. What do I mean? I mean by that, what are the level of each factor? What is, how many factors do I have to have? 2 factor, 3 factor, 4 factor, 5 factor. Let me tell you from now, the lower the factor, the better your result is. The lower the factor, the less than your result is. And normally I give this one to my student. I told them now, if I ask anyone in this workshop today, I ask him, go and make for us soup ayam. Soup ayam, everyone can do. We just take the chicken, put it in water, add to it salt. Give it a time, go take it, eat it, full stop. Not only chicken and salt. But if I add the factor, I add to it carrot, become 2 factors. If I add potato, 3 factors. If I add tomato, 4 factors. If I add lemongrass, 5 factors. If I add, for example, any more veggie, colorful one, 5 factors. That means the more the factors, the more complex the result will be. Therefore, please be careful about your factor. Then you succeed in your factor. Then from level of your each factor, you have to type of your factors. Variable only, that means factor, okay? Or variables and attributes. If your variable attributes for factor here, then you choose here if your factor less than 3, less than or equal to 3, then you use full factorial design. If your factor between 4 and 7, then you use. If your factor between 6 and 7, use the Takeuchi screening. Your factor less than 5, then use central composite design or box bending. This is the secret, brothers and sisters. I summarize here all. Here, if your factor here, level of factor 2, I have 2 level of factor. Here I have 3 level of factor here, 2 level of factor. But here, the factor itself, K, less than 4, use full factorial. If your factor equal 5, use half fraction. If your factor is 6 and 8, then 16 run fractional factorial design. Your factor between 9 and 11, then use scaling, run bracket board or touching. Those are the issues. Is that clear for all? I will repeat this one again. How you decide decision tree for choosing an experimental design. Do I need to have DOE to be identified? Yes. Did you define your problem objective? Do you know exactly what is your problems? What are your objectives? Yes. Then now you come to third part. Define matrices for your response. Do you have level of each factor? Level of each factor, 3 level or 2 level? 3 level factor you have. Level of factor, less than 3, full factor. Between 4 and 7, Takeuchi. 6 and 8, 6 and 7, Takeuchi screening. Factor less than 5, then you go to central composite design or maximum. If you have the level of each factor 2, but the factor here less than 4, full factorial. Factor equal 5, half fraction. Between 6 and 8, 16 run fractional factorial. Fractional could be quarter, could be 1 over 8, could be 1 over 16. It's a matter of multiplication 9 to 11, then 12 black. This is the one. The first one, most of you, they or has been done a long time ago, is one as of one factor at a time. One factor at a time. And you perform an experiment on a new piece of equipment. So the function, say for example, that a function of 3 factors: cooling temperature, I may have air temperature, or I may have metal temperature. This one for mechanical, analytical, or whatever. Have cooling temperature, degrees Fahrenheit, air temperature, metal temperature. The objective here was to maximize the response. Why? I would like to maximize the response. In this case, part 5, the engineer performed the experiments as a 1 factor at a time for 3 factors in 15 runs, as you can see from here. This is what did I do. Then I put it according to what you can see here. Cooling temperature, 600, 700, 800. This what did I do yesterday in design experiments. Air temperature, look here, what did I do? I make it constant, 2,500, 2,500 or. Metal temperature, 1,900. In most of them, I change here. Right? So look what happened after that. We can estimate that effect, both linear and quadratic. However, we cannot estimate interaction. Why? Because this is 1 factor at a time. 1 factor at a time, that means I have only temperature in degrees Fahrenheit, what happened to it, metal temperature, air temperature. But there is no interaction between them. This is why we are not for a 1 factor at a time, just to explain to me the range that I want to conduct my experiments. It is not a full experimental design. Why? Because there is no interaction between them. But it gives me a prediction or initial estimation for my cooling temperature, for my metal temperature, for my air temperature. This is what do I mean by offer, 1 factor at a time. 1 factor at a time, what are the pros? It's straightforward, easily to understand. From here, as you can see from here. Very easy, straightforward. I know what one is very high temperature, one was high temperature, one was the high temperature, when, where, how much time, etc. All of this one, straightforward. Cons, impossible to address interaction. Only 1 factor is valid. Tends to over-collect data, not efficient sample sizes. I don't have sample size. Result, the experimental space is not explored sufficiently, and the optimal solution may be missed. Definitely may be missed, because it's one now in for the fixed time. Here I make force temperature. Here that means there is no interaction between them. Here I have pressure, speed, and time. I don't know which one. Here is the optimum. Therefore, I'm not preferred. Single factor experiments is known as 1 factor at a time, multiple level, 1 level at a time. Analysis isn't efficient. Consider 1 factor with 5 levels. Pairwise comparison requires 10 pairs. If each comparison is alpha 0.05, then probability is 1 minus alpha raised to the power of 10 is 0.6. Therefore, that means 6% only is accurate. The result is not so that accurate. That's why we don't want to go for offer, only for introductory issue. Okay. Now, design experience, this is the one factor. This is what did I do I do yesterday. Now you open your want to design here. Experimental design. This one I did yesterday. This one, it comes to your accordingly. I choose here for response surface, 1 factor. So please, all of you, be attention. I go here. I go to response surface. I go to 1 factor. 1 factor. Here, 1 factor. For here, numeric factor between, this is only 1 factor. Category of factor can be between 0 to 10. 0 to 10. Central point, only central point you want to have. Model, is it quadratic? Is it linear? Is it cubic? What really you would like to have at the end of the day? depends on you. So let me go back. And this one come by mistake. And this one. So I see here, let me go into of this one. Yeah. What are the here? Fraction and factorial. You choose only one factor. Then you choose here how many center point. If you have one, then you may have run. Explain to you how many run that you will have. So this one factor at a time, one factor design. As I mentioned, not perfect. Then how you go design experiment, response surface, one factor. You can do over there. If we go to the second one, full factorial. What are the pros? Full evaluation of individual and interaction effect is what most preferred. Most efficient design with respect to sample sizes. Cons, more complex to explain to untrained audiences. If you are not trained, you have your result, but you say, I don't know what to do with my result. Right? Full factorial are all included in the experimentation. In full factorial, all the possible combinations that are associated with the factor and the level studied. Here you can have general notation, two-level experience. That means 2 raised to k, where k is the number of factors. 3 level of k, that means 2 raised to the power of 3. Factor 11, example of 3 factors, 2 level, as you can see here. A, B, 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 C, C, A plus A, minus B plus B, minus C plus C. Or I may have A, B, C. Those are the interactions. Full factorial design, as you can see here, 2 raised to the power of t. I may have combination as of A plus B plus C, or A minus B plus C, or A plus B plus C. I make a constant, then I change the sign. Then A finish from here, A, B, C, A minus B minus C, A minus B minus C, and so on. That is here test 1, 2, 3, 4, 5, 6, 7, 8. Effect evaluation, effect of single factor A, B, and C. Second order, that means I look after 2 factors, which is the interaction between A and B. What do I mean by that? To put you on the right track again, always remember the story of the cake making the on the floor, on the egg, on the sugar. Am I right? Egg, flour, and sugar consist as A, B, and C. A means egg, for example. B, sugar. C means I'm talking about the flour. But that one is not alone. I would like to look after a combination between sugar and egg, sugar, flour and sugar. This is what I mean by that. I would like to look after the interaction between the 3 of them, A, B, and C. Egg, flour, and sugar. Are they interact to give me the appearance at the end of the day, and the taste, and the color? This is the meaning of that. Advantages over one factor at a time, more efficient time, resources sample size, address interaction. This is the most important issue. Provide insight over a range of experimental content, as you can see from here. A, B, and C. Right? Then I have here A, B, A, C, B, C. Then I have A, B, C. So this is what I mean by that. A, if I say egg, if I say flour, with flour. C, if I'm talking about sugar, for example. This is the interaction between them. So this is what does it mean by full factorial design. Full factorial design include all possible combination of the effect, which is egg, flour, and sugar, for example. Design becomes very large as number of factor increases. Now we'll talk about only 3. You can imagine now if I add to it another factor, color, together with the flour, sugar, egg, I add to it, for example, color, become what? 4 factors. Am I right? So become complex. I may add another factor, salt, become 5 factors. So the matter become very complex. Size increase more quickly when designs are replicated and center points are added. I'm going to explain why we are relation and center. Useful, for example, smallest example number of continuous or 2-level factoring. It's very good in that. A full factorial design experience is easy to build on paper. Small to medium size design can be created graphic large design can be created on a spreadsheet or computer. Choose high or low values for each factor. For example, temperature between 10 to 25, concentration between 10 to 30, pH between 4 and 10. Let us now do this one together. Let us do this one together. I will go to for full factorial design. This is the one. Yeah. I'll go for factorial. Please, everyone follow with me. Factorial. Factorial. How many factors you have? 3 factors. Replicate. Yes, I want to make replicate. Make 3 times. Block only 1 block. Center point. Since I have 3, then normally they say that you may have 2 center point. Or this, let me choose here 2 center point. Then you go here. Continue. Look careful again. What did I do? Here 3. Right? Then this one. I'm going to explain to you in short what does it mean by red color, green color, and yellow color. What does it mean? I'll show it to you in short. Right? So I have 3 replicates, 1 block, 2 center point. Then I continue. This is not enough statistical for recommend to add 4 center point. Now see, recommend adding 4 center point to a design. Let me explain to you. Add to 5 person. Then tell you, then let me go back again because you recommend me to have 4. I choose 4 center point. Continue. Continue. Okay. What is A? A here, he say, according to him, A temperature between 10 and 25. A right here, temperature. The unit, degrees Celsius. The value here, look, I have 2 things here. Either numeric or categorical. Numeric, that means value. Categorical, that means qualitative. Qualitative. Here I'm going to take numeric between 10 to 25. This is the first one. This is the lowest point. This is the highest point. The lowest and the highest. The second part, what do I have? According to this one, concentration between 15 and 30 nm. 15 and 30. Concentration. I'm going to limit concentration. C-O-N-C. Then unit N, capital M. Also, numeric, it's between 15 to 30. The third one, I go back, I look after here, pH between 4 and 10. pH, it has no unit, right? Between 4 and 10. Okay. Now I go continue. You ask me how many response you have. I would like to more than response. Again, remember the story of the kid. You are concentrate only about the test or about the appearance or about what? So now I also ask my student always to have only 1 response. Say for example here, the response here, for example, effect of whatever. Okay, continue. Look how many run now you have. 16 run. This is the run. This is a block. Then he put each and every block together. Put factor number A, temperature in degrees Celsius. Between we said initially between it is between 10 between 10 to 25. To 25, I have a point, just 17, 10, 25. All of them appear here. I have another one here between factor here for concentration between 15 and 30. Those are center point, right? 15. Concentration between 10 and 7, 4 and 10, sorry. This is center point or center point. Then you run now your experiments. You put all of those together. At factor number A, put temperature 10, concentration 15, pH 10, then you put your answer here. So for example, 55. Then you have here 67. Then you have here 34. Then you have here 90. Then you have here, for example, 89. You have here 67. You have here 56, 66, 88, 99, 57, 84, 58, 58, 90, 45, make it, for example, 78. Your result. This is the result that you, after you conduct your result. This what did you do? After that one, you come to, now then I come to my design. I look after my experiments. Those are temperature between 10, lower value, higher value. This is a coded one, minus 1, the lowest one is equal to 10. Higher coded, that means 25. The mean equals 75.5, because mean equal, those two together divided by 2, 17.5. 30, 45 divided by 2, 22.5. 4 and 10 equal 14 divided by 2 equals 7. This is what the first thing you have to look at it. That one we go into detail. Is it clear for all? Okay, it's clear. Let me continue now. So now we understand you can put the lowest value as of -1 or +1. Minus or lowest. Or you put the values as you can. -1 that means 10. +1 that means 25. That means the lowest and the highest. Right? Center point. Center point is something added to a factorial design to estimate the curve relationship among the factors. What do I mean by that? That means this center point, very important, because we say that the pH temperature between 4, say for example, between 4 and 10. But center point, that means the absolute value could be here. Could be 7. Could be 6.5. Could be whatever. So therefore, I add center point, as you can see from. Same thing, go to temperature. 25. Then I have center point. 1. Same thing, go to concentration. So center point is added to a factorial design to estimate the relationship among the factors. Measurement from 3 points, the curve. Take that. That is the absolute value or the optimal value could be at that point. Regular factorial design only use 2 measurements, high and low. A single center point is defined from middle point of each. Here, 17.5, 22.5, and 7. This one, the middle center point. Right? So now this is the one I'm experimental design, the one right now I explained to all of you. What I want you now to look at me carefully. If you look here with me again at this diagram, let me now go to make new one. Yes, I say. Look now here. I want to explain what do I mean by red color. What does that color means? Many students they just realize you can calculate the coefficient of n-1 factor and interactions. Say for example, for 2 factors, you can calculate the coefficient for 3 factors and interaction, A, B, and AB. So it is not interesting to raise 1 experiment and lose information possible interaction between A and B. That means green color, it comes to you when you use, for example, 2 factors. So immediately come to you into green color. And you have here in the form interaction between A, B, A and B. This is why here we have this green color. As you can see, if I go here now, those two, I have this one. Great. That means all my work here, all the possibility of the range is in green color, either here or top of this one, green color. This one the interaction, A, B, or A and B. This is what do I mean by that. If I have, for example, I go with experiments, you can calculate the coefficient factor again. Say, for example, for 3 factors. 3 factors, that means 2 raised to the power of 3 equal 8 experiments. You can calculate the coefficient for 7 factors, A, B, and C, interaction between AB, AC, BC, and ABC. 1, 2, 3, 4, 5, 6, 7. So you use semi-factorial 2 raised to the power of 4. That is for experiments, information, possible interaction are also lost. Therefore, my main work, you'll find it into red color here. That is interaction will go to up to red color. As you can see here, interaction. Those possible. If I go here to 2 raised to the power of 3, that means it could be between here and here, red color. Those two include. 1, 2, all of those one include the interaction will be included. The third one, the green color, the yellow color, it comes into form also experiments of interaction. More than 6 factors, the number of factorial testing, the number of single interaction. That means I never found up to now significant triple interaction. We never found triple interaction, A, B, and C. Very difficult. Then, in such a case, why I have to lose time? Why I have to lose money? And why do I have to have large number of such interaction? A, B, C, D, E, F, etc. That one normally come into yellow color, and it is not important to have those interaction A, B, and C. This is why it comes to you into yellow color as what you can see already. That all of this yellow color is not going to be added at that experience. Because it's costly-wise, money-wise, wasting time, etc. That's why the experiments, most of the experiments, it come into single factor here, or interaction here, and or interaction between 2 factors, green and red color. And as much as you can avoid this yellow color is not important to have. Right? So this is what become the colors of our experiments. So 2 factorial method, symbols of 2 factorial, as you can see from here. Say for example, I have factor A and factor B are in this equation. So a single replicate of this design will require 4 runs by default. Those 2 factors considered as A and B. So therefore will be 4 combination, 2 raised to the power of 2. Say 2 level, high plus 1, low minus 1. So possible combinations are illustrated as follow. Run number 1, run number 2, number 3, up to run number 4. I have positive positive, or positive negative, or negative positive, or negative negative. Positive positive means higher and higher, higher and lower, lower and higher, higher and lower and lower. So this is the response I add to the diagram. This one for replicate number 1. Replicate number 2, I do the same experiments. So therefore, here give me response 33, give me 30, give me 52, give me 60, give me 10, give me here 26, give me here 20. So this one, the replicates. So look now what happened. The main effect of A, main response at level, minus mean effect at the second level. 30 plus 50 divided by 2, minus 10 plus 2 divided by 2, plus 20 minus 50 divided by 2. This one for A here. All A. 30 plus 50 divided by 2, 30 plus 50 by 2, positive, positive, divided by 2, or 10 plus 20 divided by 2, 40 minus 15 divided by 2. Same thing go to for effect of B. I go for interaction, A and B. 30 plus 20, 30 plus 20, here, interaction. What is the interaction here? 30, this one interaction, A and positive and negative. 30 and 20 divided by 2. 50 and 10 divided by 2. So interaction outcomes, as you can see from there. This is for this case. Main factor, this one alone, for each factor A, factor B. This one for interaction. There is no relation between them because they are parallel. Therefore, now your interpretation, now you add. What is your interaction response? There is no interaction between them. Right? So, therefore, enter the name of response. Select the goal, select the factor, enter the factor name and setting, center point, say for example 6, enter number of replicate, here 4, number of run, auto populate at factor of time. Let us do this together. let us do this one together. Then, for example, now I would like to select factor of 2. Factor of 2. Here, this one. Factorial, I go to factorial, factor of 2. He say how many replicate? 3. How many center point? I choose 6 center point. According to what I have over here. Again, let me go here. Select 2 factor, enter factor name and setting. Center point equals 6. Number of replicate, I make it 4. Let me try both of them. If I make here number of replicate 2, first of all, and center point equals 6. I make here continue. I name it temperature and concentration. Right? I make continue. Response equal effect. See how many run I have? 14 run. What? How many replicate here I have? 2 replicate. Right? Let me assume I don't want to have 2 replicate. I want to have 4 replicate. Let me go back again. Look, the good thing about the front-end design, ask you the question, self changes to my design? I say no. What he asks you, use previous design measures, so I'm not wasting my time. Here, rather than replicate 2, I make 4 replicate. Center point 6. Then I go, continue. Remember, the first one was 14 experiments. Everything same, replicate, same. Look now how many experiments I have. 22 experiments. 22 experiments. That means me, I test all the possibility, and I have enough time, and have enough resources, and I have whatever is enough in my hand. Therefore, I can run my experiments. This one for only 2 factors: factor A, temperature, and concentration. I would like to see the effect of the response, whatever it is. Is that clear for all of you? Clear? So this is regarding the two replicate, as you can see from here. So nextly, this is on the one same thing. So I have 22 response to 22 run. That means run, that means experiments here, right? Therefore, run your experiments accordingly, and you have your out. Set 6 center point and 22 run. Here, according to DOE, low, 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 high, positive, positive, or negative, 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 positive, negative, positive, negative, 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 positive, positive, and so on and so forth. Factorial statistics, normally here we look after ANOVA. I look after standard deviation. I look after coefficient of variation. I look after R squared. Those are the factors that you have to look after when you come to analyze your 2 factorial. Those are the factors that you have to look at them carefully. That's why I put it to you here. ANOVA, standard deviation, coefficient of variation, R squared, adjusted R squared, press, that means predicted error, sum of square, and linear regression. Those are the factors. I cannot go through all of this one right now because of time consuming, but I will come to it if I have a time. And this is what I do that we may have another session for this. Factorial statistics, test of significant overall model response. What is it? What is the individual coefficient? That means each and every one. Look at it. You start to interpret. The effect of temperature is very important because without temperature is going to have this and that. This is what you would like to have in your report. Diagnostic test, you look at residual, outlier, lack of fit. Lack of fit. That one also I will explain if I have a time. That one regarding the full factorial for 2 factors. Now if I talk about fractional factorial, look at more factors with fewer runs. Yeah, because I don't have enough time. I don't have enough time. Therefore, a way to use huge full factorial to sometimes manageable, you consideration, I don't have enough time. I don't have enough resources. Complexity of setup for experiment. To set up the experiment itself, very complex. Therefore, I will go for fractional factorial method. Major use in screening experiments where the knowledge of basic effect is not well known. If 2 over k is very large, may need to run reduced experiments. Fractional factorial design are derived from full factorial matrices by substituting higher order interaction with new factor. That's all. But it is correct, nothing wrong with it. This one for 2 fractional factorial. Now And I want to try to you now. See this one just for explanation for whatever I explained before. Now I come to scaling experiments. We use traditional way design, full factorial and fractional factorial design, or bracket Borman. I mentioned to you there is new software is known as GMP. If you go through it, try to search about it. They have also session into it. I'm really like it. This is why I added in today's session. This one, the most new software used for experimental design, known as GMP DOE. Very, very good. Screening for full factorial design, custom design. I cannot go into detail because not part of my study today, but I advise you to go for that. So therefore, I use those two, full factorial or fractional factorial design or bracket Borman design. Fractional factorial design, certain combination of the factors are omitted to create a smaller design. Omitted design point cause aliasing of the interactions and main effects. Fractional factorial design exists for different numbers of factors and reduce. I, number of factor level. P equal fraction of the design, as you can see from here. Those are the three factors that interact. So fraction design are describing that I, K minus P, number of P fraction of the design. So assume I, number of factor, 2, number of factor level here, 2. Factors, I have 3 factors. And P fraction of the factor, minus 1. A to the power of 2 equal 4. Therefore, I can reduce it to 4. Plan very efficient for testing large number of predictor samples or variables with a small number of them. Bracket Borman has been estimated in 1964 based on Pali construction of Hadamat. Only significant interaction arising with me. This is what I have example x is up to x11. This is a pattern. Each column denotes a unique factor. -1 and +1 interest represent higher and low values. The pattern of -1 and +1 interest represent the Pali construction. Fewer than 11 factors can be used if some factors are omitted. This one, can do it right on this one. Bracket Borman, 12 run bracket Borman. As we see right now from here, I go again, then I make again new, save, no, use, maybe I say no, because I'm not interested in it. Then I go to where? I go to factor Borman. Factor 11. Factor, say would like to use 11 factor right now. Center point, I don't have it. Then you can name them. Lower level, you can name them. For example, here, you can name it between 2 to 3, 3 to 4, 4 to 5, 5 to 6, 6 to 7, 7 to 8, 8 to 9, 9 to 10, 10 to 11, 11 to 12, 12 to 13. And here, bear in mind that you use numeric, not categoric. I'm going to show you category after a while. Center point, if I don't have this one, system I don't. Continue. Response, name it whatever you would like to name. So those are the 12 run. Those are the tests. So I'm going to test you each and every one alone. So you put your result here. This is what's meant by screening. So from here, based on all of those one, I look after the best one. What is the best among all of them? Then I choose this one, then I go to full factorial design or response interview or whatever I would like to say. This is what's meant by screening using Blackhead Borman design. So, even two-way interaction are not significant. They literally screen the factors or variables, the process, that determine which are the critical variables that affect the process output. So therefore, we can do this one history about it. Why we use screening experiments? One will factor would like to save money, save time, because I don't want to use all of them. Very big number. Like to use the best among them. Single multi-factor experiments can utilize larger number of variables. Multi-factor experiments allow researchers to detect important interaction between variables and interactions. So therefore, I would like to look after interaction. From only two levels between up and high. Use only if you can reasonably assume no two-factor event. I use Blackhead Borman. I hope this one is clear for all of you. Use it if I'm quite sure there is no two interactions. Okay. This is why I put here no two-factor interaction. Therefore, I use Blackhead Borman design. I use okay to give you number of runs. As you can see here. Conclusion, it is or several array OA, OA, all effects and no interactions. Special attention must be paid to the alliance structure for action at both design phase. The one 2 raised to the power of -1. I K minus B. That means 2 raised to the power of 4, 16. 16 and 4, factor A, B, C, D, E, 5 factors. Negative, 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 that means small value. Now this is what the computer gives you, randomly. So this is a yield. The output, this is one value. The interaction, as you can see, comes some type of view like that. Any question before I proceed? Now the time for the break. Time for the break, so as not to fail more from it. So now we are in break. If anyone has any question, I can answer right now, while the other people, they can go for the break. Someone asked how to response surface, one factor. This one factor. How many factors do you have? One factor. Now here, category factor. Say for example, I have 7. Center point, I have, say for example, 4. Quadratic. Then continue. 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 So this is the level. This is O factor. Level of 2, level of 3, level whatsoever. Those are, if you have those, all of this one. From those one, they would like to select the best one among it. Then you put your answer here, then you will have. This is what is meant by O factor. One factor at a time. And this one, as I mentioned to you, I'm not because it only gives me initial factor. Yeah, what is meant by block in DOE? Block in DOE, as I mentioned to you, say for example that here I have here. This block number 1 is going to all factor here, level 2, level 1, level 3, level 3, put all of them under this block. That means as if going to summarize the whole experiments which concerning, they have the same feature, put them into certain block. This is what I mean by that. The other one, give you into another block, block number 1, block number 2, etc. So I give you in all blocks. So this block concerned with those type of experiments. This block here concerned with all of those. This block concerns all of those. This block here, put all of those one which is related to each other, they put them together. This is what is meant by the block. How to use the center point? It will be given software and based on what to choose the right center point. Okay, very good question, this one. Let me also sometimes, and especially let me go back again from here, from beginning. No. Two level factor. Yeah. We said normally replicate, use 2 or 3. 3 the better. For even the much better, the higher, the better. I use 4 replicates. What I put here, 1 center point. Look what will happen. Continue. Look here. Immediate curvature with 1 center point. What do I mean by curvature? That means when the system starts to run, center point or the optimum value could be, if I talk about between 4 to 5, pH 4 to 7, or pH between 4 to 10. 4 to 10. Center point is supposed to be 7, right? But the optimum could be at 6, pH 6, could be 6.5, could be 8, could be 8.5, could be 9. But it's not shown because I put only select 1 center point, which is 4, 7, and 10. 4, 7, and 10. What about 5, 5.5, 6, 7.5, 8, 9? What about them? You never study them. That's why here they tell you, no, we're recommending 4 to 5 center point to design. Do you want to continue with this number of center point? Yes for continue, no for cancel. Or sometimes even I choose 6 center. That's for me the whole possibility. Therefore, I look here, continue. Look how many run? 22 run. Let me go with you. Let me assume with you now, you insist to have only one center point. Do you want to save? I say no. Yes, I say yes. I say here center point, only 1 center point. Run, other than to use 4 run, I use only 2 run. And I insist, no, I'm correct. I don't know that he gave me this answer. I ignore it. Say, this guy only. Then continue. How many run you have? 9 run. You can imagine now, your test your experiment was 9 run. Answer is very clear, am I right? This is the reason behind why to have command for the report. So, okay, another question. To choose center point. Okay, if I have only 3 factors, should I screen them? No need. You can go directly either to RSM. It depends on, do you want to go for modeling or you would like to go for optimization? If you are looking at optimization, if you are looking at, you can go for full factor design, as I am going to show. Say for here, go for new. No. Here I have 3 factor. Then I come here. I choose this one here. Replicate. I choose here 3 center point. I choose here 6. Right. Then I go here. This one for 2 level factorial. I go for factorial. 2 level factorial. Continue. And then we would like to get. And then you have how many run? 18 run. I use here full factorial design. This one, if I would like to have what? I would like to have modeling. But if I'm looking after optimization, I say no. Then I go to for RSM, response surface methodology. How many number of factor? 3 number of factor. Then full factorial. Enter factor here. Alpha options here. 6 center point give you direct. Center point give you direct. Number flow 1. Enter factor ranges. This one you can add later on. Then you might here continue. Name it what you would like to name. Only ones. 21. How many run now here? 20 run. Give you another. This is the minimum. So it depends on you. What is the purpose of your experimental design? Because the purpose of the design, you succeed in that one. I hope I answered the question for Brother Brian. If we have 3 factors, do we need to have interaction 3 at the same time, or 2 is enough? If recommendation of interaction, as I mentioned to you, for 3 factors, you are not going to say that I have 3 interactions. The system will give you the answer by itself. It depends on your study, because at the end of the day, on your analysis, system tell you there is 1 interaction only, or 2 interaction, or 3 interaction. But as I mentioned initially, it is very rare to have 3 interactions, only give 2 interactions. So you are going to, the system is going to advise you. You are not going to force it. Okay. Optimization, yes, directly for RSN. Directly for RSN. Don't need to go for. Okay, then I will go now to take my break. I will just drink water and come back. Okay, let me stop this one. Okay, Abu Abdullah Rahman, he says that if I have 2 factors, cutting speed, meter per minute, and feed rate, revolution per minute, with 3 level, each one can and yeah, that one you can use here, full factorial design. As you can see from here. No. Here, you have here, okay. 2-level factorial. I choose here 6, replicate here, choose 4. Numeric power, whatever it is. Continue. So this one, your response is supposed to look like that. You have to have 22 rows, if I'm not mistaken, if I understand the question properly. Three level and one category factor. What do you mean by 3 level and 1 category factor? So, Kabbashi, you can see at the end of the class, you may contact me, I will show you what you have to do. Okay, Bismillahirrahmanirrahim. We are back now for the last part of this session. Whereby now we explain about experimental design, why we need experimental design, the factor for selecting experimental design, strategies for your selection of experimental design, the different type of experimental design from OFAC, two-level factorial design, full factorial design, fractional factorial design. What else? Takushi, Lucky Borman, box banking. So there are other type of experimental designs that we have. 3 level for K for K factor. 3 level for K factor. Here K factor is 3K factor. Or fraction 3 level design. Fraction 3 level design. Then you're adding center runs to get estimate of process variability, familiarity with the process, identify system performance analysis. As you can see from here, this one. Yeah, I hope that it is out here. Yeah. No. Here, what do I have by that? Here we have response surface methodology. Combine those the point that we never discussed before here. Combine or unify, or you may have mixture. That mixture may use any of those distance speed, historical data. You may have mixed component, whatever amount you like to use here. Here we have the optimal, the one that I'm going to explain to you right now. Here, mixture design, where one or more factors are constrained to add to something. For example, you will have constraint like x1, x2, x3, x equals 0. Example, a mixture of contributing probabilities. Here, we use mixture design. This one. Mixture design. Mixture design. Then you can either simple lattice or simple or screen. Even on the screen, with the optimal, you would like to look after optimization from mix. So what you would like to study carefully. By your knowledge, I mentioned to you, each and all of this one, I do have one textbook, complete textbook for the whole experimental design, explain to you when you have to use simplex latex or I will pass it to PGSA. You can collect from them. It is PDF file because this one is in and the second also you need to PGSA, please collect from them. It will help you a lot when you would like to select, because it gives you a very clear picture. Why I have to use simplex lattice? Why not simple centroid? Why not give up? Give you the of that one. Because even here, explain to you in a very low way. Nested and split, plot design for experiments with random factors. And this one also sometimes we need nested and split. Like this, I have it somewhere there. Even this one, every time there is some improvement. Yeah, normally they give it here. It's not in this one, but in the new one, the new version, they have nested and split. Nested and split design. Okay, we have also another one, irregular fraction. Usually a resolution V designed for 4 to 9 factors, where each factor is varied from over 2 or 2 level. 2-factor interaction allies with 3 factors and higher, extend to reduce number of runs and still get clean result. Irregular fraction. You can see here. Irregular fraction. Normally come from 4-factor and 4. If you have any factors, you can go for irregular fraction. Give you a very good result. Very good result. Center point here also you can select element view. You may have. Let me assume you here now I put only one. See what system recommend. I never recommend that means I can use any number of factors. But normally, mention view I prefer to have more than that. Here I have 3. Then you continue. Then you have 15. Run irregular. Then decide your factor is. This one regarding irregular factor. General factorial for 1 to 12 factorial, where each factor may have a different number of limits. All factors treated as category. This is a question that now has been asked by one gentleman. General factorial. Here, I know it here. No. General factorial. This is a question now has been asked by this gentleman. General factorial, I have here, for example, 3 factors. I go continue. Name, you name them, it gives the unit. The level, how much level? You say now you have, according to, I don't know, we say 2 level or 3 level. I will cross over one. I have 2 factors with 3 level. Let me go back again. Go 2 factors with 3 level. Level here. 3 level. One more 3 level. Replicate 4 times. Continue. Response, 1 response. Then look here, we have 36 run. 36 run. You will have this one for irregular. That one also very good one. We can use it for 1 to 12 factor, where each factor may have different number of levels. This is when we use general factor. The optimal special design for categorical factors based on a list specified model. Design will be a subset of possible combination generated to minimize the error associated with the model coefficient. The optimal. Here. I go no. Okay. The optimal. This is all. And you can go. Right. There must be at least 1 mixture component. Mixture of 2 components. Yeah, here you can use 2 mixture. Number of factors 2. Category factor I have 2. Then continue for naming all of them. Now unit, how many levels? You have 2 levels or 3 levels. Let me assume you now have 3 levels. Continue. Here I have 2 levels. Continue. The third one. So therefore, this is the same. And continue. Are you sure you want to do this? It will take a long time. You might want to reduce the number of random pulls per error. Okay, then explain to you here. That means he explained to you that if you go for this one, it takes from you very, very long time. No, I say no. There are rows. Please check your input data. Then you need to go back. That means something going wrong here. Therefore, this where is the mistake. Because the system is not enough. Whereby I explain to you that means something going wrong in your data. This one for optimal. The guide selection now for overall for each and everyone to understand. If you have number of factors, you have one number of factors. Then you can use one-way ANOVA or simple regression. Screen objective, no need for screening because only one. What I'm going to screen, no need for me to screen. If you have number of factors 2 to 4, then you can use two-way ANOVA or you can use general linear model. Here is screen objective. You can use full fractional factorial design. Before this one, let me go here again. Go here again. I go for new. Let me assume with you now. I have 4 factorial design here. 4 factorial design. I have replicate here 4 replicate blocks. Continue. Continue. What do you have here? 24 run. 24 run. Okay. Let me assume with you now. No, I say no, this one is not the proper way. Then I go to this one. If I go here for full, if I go here for here, replicate, I make it to replicate. I make here 3 center point. Continue. Continue. What do I have here? 35 run. 35 run. 35 run, but it seems to me that this one is too much on me to have it. Why? Because I use full factorial design. I say no, I don't want to go for that one. This one here, I choose full factorial design. Here I would like 2, 3 minus 1. Now, here I do the same thing, replicate 2, center point 2. Say 2 to 4. I choose here 4 center point. Continue. 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 Look now, what did I do? I reduce our number of run. From 35, I make 1. This is what is known as fractional factorial design. Fractional factorial design. From where you have from here. This one in full. This one fractional factorial design. This one in full. This one 4 minus 1. This one in full. This one in full. This one in minus 1. This one minus 2. So each and every one gives you certain level of fractional factorial design. I hope this one is clear for all of you. If you have 5, number of factors 5 or more, then you use randomized block diagram. You can use here fractional factorial design or blackboard, either or. Both of them are correct. So this is a summary for selection. Linear model that means give you a straight line. That means this one way is give you for acidic, for neutral pH, or for basic. Same thing going to explain to you. So we're going to explain to you, for example, between temperature and binding agent. One way ANOVA analysis and simple linear regression are 2 familiar kinds of linear model. ANOVA methods are used to compare mean response level among groups. For example, neutral pH binding yield is significantly higher than acidic or basic binding. This one now, your interpretation. Neutral pH binding yield is significantly higher. This is what we mean. Significantly higher, neutral, very clear. Significantly higher than acidic or basic. This one the acidic, this one the basic. Yes, sir. So it's very clear. This is what meant by interpretation. Regression explore linear relationship. For example, for every 1 unit increase in temperature, bind will increase by 11.62. How do I know that one? Now, look at the temperature. 10, 11. See what happened here? See increase here. If 12, that means increase. Increasing by what? 11.6. This is what we want you to understand. By increasing of temperature, by between 10 to 11, this one the 11. So look what happened. This one 10. The value 11 increase, 12 increase by value of 11.62 units. And even if you put your mouse here, directly give you no need for you to measure it. They give you the rating immediately, because it is user friendly. Extension of linear multivariable ANOVA compares me among 2 or more, for example, cell line and culture. If I have here, for example, serum, and I have here a staff, and this one normal culture. So therefore, multiple look at the association of two or more continuous predictor with the response. Analysis of covariance includes both factor effect and continuous predictor effect. This is so that is going to explain to you. Together, add them together. Those one, two together, add them, give you the answer. What happened to them? Right? Model, that means we look after the control input and control input. Control input like what? Like what? For example, my salt, I need, for example, sugar, constant amount of sugar. This is what meant by control. But I don't know how much amount of wheat flour I have to add every time. This one uncontrolled input. Then reach to an optimum value. Is the meaning of that. This is a model, and this one your output. This is what meant by control and uncontrolled. Response variable determine the appropriate static model for the experiments. More continuous responses use linear model, especially for in case of the yield. All categorical responses use generalized linear model. Response measurements are taken from the units of sample data in the experiments. Sample unit may be selected from the population or assigned to the treatment in many different ways. Sample units may differ from experimental units. That means it depends on experimental unit. Are you talking about from chemical side of view, mechanical side of view, electrical side of view, mechatronic side of view, material side of view? So therefore, then you can look after your different ways of your analysis accordingly. Continuous variables can be treated as factor if researcher only used 2 to 3 replicated value. And by the way, for the replicated value, because also some students question, say what's meant by replication value? Do I have to, after I finish this, have to do it again? And again, no, it's not like that. Replication already coming together, as you can see from here. This is the test. Say, for example, I have here, this is a full factorial design. This is a fractional factorial design. Then I make, sorry, for that one, replicate. If only one replicate, let me continue. Whatever it is. Whatever it is, only one replicate. See how many run? Only 4. Am I right? Something going wrong, definitely. Definitely something going wrong. Let me go back again. Say no. I see here. Replicate, I make it 4. I make here a center point. I make center point. I make it. Continue. Look now how many run. 21 runs. That means it covers for me the whole possibility. That means automatically here that replicate is inclusive inside 3 runs or 4 runs already inside. And you know the difference between this one and the first one. The first one gives me only 4 runs. Only 4 runs, 4 experiments. Now when I replicate, give me 21 runs. I hope this one very clear for all of you. So no need you to do this experiment after you finish it, do it again and again and again. You waste a lot of resources. Why we go for experimental design? We go for experimental design to reduce all of those wasting of money and of resources. So no need for you to replicate because already replicated inside design from the beginning. And this is what I explained to you or what I showed you right now. I hope that one is very clear for all of you, especially for master and PhD students. Okay, here when we are ANOVA, we look after the neutral value. Here I look at the highest value. Here, power. Look at the highest power. It's very clear. This lowest, this is the highest. 2.8, 10.4 from acidic to basic and the optimum. That's it. Very clear. Uncontrolled inputs are measured rates of sample unit that do not interest in the researcher, but must be included in the statistical analysis. Yes, it's not part of my study. That means I don't care about RP, revolution per minute. But I care about temperature, say for example. But without revolution of speed, the car cannot go, or the sample cannot run, or whatever it is. What is very important. Uncontrolled categorical variable used as factor. For example, gender, race, disease status, cell type, smoking status, all of this one considered as uncontrolled categorical variables, gender, race, etc. Uncontrolled continuous variable are covariate as of body mass, calcium intake, cigarettes per week, etc. Uncontrolled discrete variables are plots. For example, agricultural plot, micro array kit, or chemical batch, or subjects. We'll talk about subjects. We'll talk about the batch, complete batch, chemical batch, and so on, so forth. Blocking variables, sometimes the phrase block variables is used to describe consecutive measurement from one factor level, only from one factor level, as I showed you previously. We might block an experience by the gender type. If we collect all the male and female samples separately, these variables may be better described as whole block effects. I hope that block variable is clear for all of you. The phrase block variable can also be described categorical or discrete variables consumed during the experiments. For example, if chemical batch is a variable experiments, you will only get a fixed amount of experiments run from each batch. For example, subject variables are often treated as blocks because one subject can only accept one treatment at a time. Even subjects considered as blocks. Now for your student, we treat it according to control variable and control variable, something like that. Sample example, almost double the sample size for half. That's why we go for partial or fractional factor design. Simple block, run 1, run 2, run concentration is a design expected. Design experiment. 1, 2, 3, 4, 5, temperature, pH, concentration. 3 experiments, one variable at a time. This is what did we do a long time ago. Now we complete all of this one. Look here, run with pH, run with temperature, run with concentration. No need. I make run with all of them. With all of them. And this one temperature, even now, I'm going to be between 15 to 5, between 4 to 10, and here between 30 to 4, and so on and so forth. Now, the summary of all of what I explained. Number one, you have to plan your plan carefully from time to time. What do we do? What do we want to have accomplished when the experience is finished? This is a question that you have to ask yourself. 2, I look after my study from model side of view, from optimization side of view, from what side of view? This is a question that you have to ask. What response in my job objective, my output? How well can we measure these responses? How well? What factors are likely to cause responses to as you write, using TOPANAS. Look at the word used, TOPANAS. That means what? Hot tea. You cannot bring for me cold tea because the factor is not there. The most factor here is what? Hot temperature. This is what is meant by responses. But this hot tea also, you have to add what? Have to add sugar? Have to add. This is why before you add the sugar, you ask the guy, how many spoons of sugar you want? Am I right? This is what did we ask? This is the response that you have to buy. How many factors can I reasonably investigate in a single experiment? Look at the word they use here, reasonably. You are not encouraged to test everything. We cannot do everything. We are human beings. We have a limit in our understanding, in our time. Everything was time. I'm not asking you for PhD is 3 years to 4 years maximum. And even now, Kulliyyah now talk about GOT, graduate on time. Therefore, you have to be very careful. And now we add, it has been added to this one now, external factors, which is coronavirus. Students are rare to come to the lab. Therefore, now you have to reshape all your objective. Discuss that one with your supervisor from now to save your time, etc., etc. So many factors have been changed. Even if you are being allowed to come to the lab, you are going to scare to get coronavirus. All of this one, brother and sister, please put in your consideration. Over what range would they be valid? Very, very important question. That one come from where? From official review. You remember earlier, I told you the weather in Saudi Arabia or in Gulf country, different from weather in Europe, different from weather in Southeast Asia, and so on and so forth. Therefore, this is why I have to have varied amount of range. So optimization and response surface methodology, this one we'll talk about it. Maximize, we use it come to you in optimization come to you in two ways. Either I would like to look after the high yield or optimal value, or to minimally value. If, for example, I would like to remove pollution, that means I'm looking after minimum. This is one. This is why that means the curve is supposed to look like this. This is what meant by 3D curve. I look at the center here, whereby this point with this point, this point going to interact to give me that value, optimal value. Or here, it gives me the minimal value. This one, the highest value, this is the minimal value. Higher and minimum, it has no meaning, just like temperature. Temperature is the feeling of hot and cold. Many people understand that temperature means panas. No, it's not panas. The feeling of hot or cold. The same thing goes to optimization, whether it is up and down. Say, for example, if I talk about fermentation experiments, I look after duration, substrate rate concentration, temperature. Those are the most significant effects in fermentation process. Any fermentation process. How much time, substrate concentration, and temperature that is. If you would like to make this fermentation to react faster, you just add more temperature. React very fast. Want to simultaneously maximize yield, minimize cost, and target specific mass of the fermentation product. Now, this one, your role as an engineer. How could I maximize my yield and minimize my cost? Need to efficient experimental design to optimize the fermentation process. So we use traditional design, either central composite design or box blanket design. This one for surface methodology. I like to have it over here. Here. No. Then I come here, response surface methodology. I use central composite design or box banking. Either or. Those are the two ones that you can want. Central composite design or box banking. This one for what? Optimization. That we have to talk about. Then you can use either or. Or you can use A&B, as I mentioned to you, this is the new software you can refer to. Central composite design are full factorial design argumented with center point and axial star point to a polynomial effect to cut the matter from each and every part. This is why we have circumscribed central composite design or composite or face center design is known as FCCC. Either or. This is why normally the student come, I ask him which one you use, CCC or CCI or CCF or FCCC. Be aware of this one. Most of the time, the student use this one, but he doesn't know which one he uses. So please be aware of this one. Axial composite design are outside design space. This one advantage, disadvantage. This one is well known. As for example, if full factorial design you use pH from 4 to 10, then axial point may be pH 2 and 12. 2 and 12. 2, that means we go 2 less, 2 high to test the whole possibilities for this CC, circumscribed design. This one is scribe, this one face center design, and this is the one that we use a lot in the Kulliyyah of Engineering. Reasonable axial center design, most high quality predicted, this is why we use it. Easy to create from full factorial design. Disadvantage, poor quality prediction. Only 3 level per factor versus 5 level per factor per CCI and CCF. Box banking, full factorial design is what samples are assigned to the edges of full factorial design, just like CMCO. Look at here, look at this one and this one. Yeah, it just use the whole possibility everywhere to the bottom interaction. While for box banking, small sample size than CC design. No unreasonable design. Why? Poor prediction. Cannot create box banking. BB design from an existing full factorial design. May not be rotatable design. If you rotate it, you may not see the other part. That's why sometimes box banking design for 3 factors. Yeah, X1, X2, X3 is the design that we have. Use of box banking. Say for example, here I have pH, temperature, pH, and particle size. Let me do this one together. Box banking design. I come. Box banking. Where is this banking design? Yes, make it design. 3, name the first one is known as temperature between 30 to 60. Temperature. Temperature. Sorry. Yeah. Celsius between 30 to 60. Just press that, then it can go to you. This is the first one. The second one, between pH, between 6.7 to 9 pH. pH, it has no unit. 6.7 to 9. The third one, have it here, is concentration milligram per liter between 34 to 38. Concentration. Milligram per liter, 34 to 38. The center point side for you, 17 round will come. Continue. Let's assume now it is product. Okay? Continue. Then 17 run, then put your answer here accordingly. This was made by box banking design. Also used for optimization. So this is the one. I put it here, I explain it to you. So rotational design is rotatable if the prediction variance are a function of the distances. The design is not rotatable, it will have regions of increase. This one, this one, rotatable to design. Non-rotatable if it is more than that. This one even can rotate. You put your hand, I can go up and down in the software. So rotatable also unrotatable. After line, you would like to test about number of children in hospital or whatever it is. Here explain pros and cons for face-center design for all-time design. Design sponsor for methodology we use for traditional. This is the one that collected analyze RSM assumption improve model fit if necessary. Already and only for normal approach. Okay, any question? Any question? I hope that I finish on time. Yeah, alhamdulillah, I finish on time exactly 12:52. 12:52. So I'm okay with any question if it is there.
We have a question in the chat. Prof,
yes.
How do we decide to choose box banking or CCD?
Yeah. On this one, very, very good question. Normally, I prefer to use full CCD as I mentioned right now. One of these, both of them are correct, first of all. No one can say anything about both of them. Both of them are correct, but I prefer to use FCCD. Why FCCD? It's going to, you see, let me just give it to you in this diagram again. But this diagram right now. Yeah, this is the CCD, right? Here, this CCF, full for face center design. So it gives you the whole possibilities in the experiment. Any possibility from any corner going to test it. While here, for box banking, no, it limits a certain point. But there's nothing wrong with it. If you want other places to use it, you can go ahead. Not only that. So both of them are correct. For me, as experienced guy, I prefer to use FCCD. It's much better for me from my experience.
Okay.
How to do validation run? Validation run, it's a very good question. After you, let me ask you. Yeah, he asked about validation run. After validation run, let me use you now. Go back to my this one here. Where is it? Let me go here. Yeah, let me go for optimization. For this optimization, let me see. I hope that I have put something here. Yeah. No, okay, I'll go for the previous here. This one. best result for this one response, assume that it is at 37, which is run number 12. Run number 12, whereby temperature is 45, pH 9.5, particle size 0.91, and mode is 37, response 37. This one, after you get this result, validate that is what? Do it again. We do it again, we see did I get the same result or the different 5%, 6%. 5-6% that means my result is validated and absolutely correct. But if you find that the result is quite different from the result, rather than to come to 7, it gives me 52. That means statistically it's not validated. There's something wrong with your test. That means your validation is incorrect. So therefore, you have to go and to find out what is your problem.
Sir, are we going to discuss ANOVA or not? I mean, how to interpret our analysis is important, lack of fit and 3D view.
This one, because as I mentioned to you, it needs, I have to put it to you in a real situation. But in general, I'm not going to discuss it now, but I'm just going to give you a brief. ANOVA, that means analysis of variance. Then I look after two things. Number one, R square. R square is supposed to be high, more than 85%. And you look after the predicted R square, supposed to be almost same, different between them, you plane. Then you look after P test, supposed to be less than 5%. Lack of fit supposed to be, what is that? Is none what? Supposed to be no. Something I'm going to explain that one later on. But I mentioned to you that it needs at least one class for analysis because I want to use 3-dimension together with ANOVA in detail. So we cannot cover it now.
Okay. Sir, as we have COVID-19 going on, so do you have any suggestion for us as a student, like how can we do design of experiment so that we can ensure graduate on time? I mean, do you have any suggestion for us?
That one, I guess this question is supposed to be, the suggestion is very simple. I guess by now, first of all, we have to be strict to SOP, which has been said by the government and by the university. Number two, Deputy Islamic and Dean of Kulliyyah of Engineering. I guess they said for us, and Deputy Dean Research and Innovation, they said to student, anyone who's supposed to come to the lab, you have to write down your name and to follow SOP. Unfortunately, some of students up to now, even my group, still I have to urge my students, please and go and register. Please and go register to have a lab. Because if you don't register your name, we are very sorry, you cannot come to the lab. Because your safety is the most important thing for us. So we cannot allow students just to come because he suddenly told me, sir, I forget. No, there is nothing called forget. It's one your own responsibility. So therefore, please follow strictly SOP by the government, by the university, and follow the instruction has been said by the Dean and Deputy Dean Academic and Deputy Dean Research and Innovation. Believe me, you can, because all the points that you have around your head within our meeting, we discuss it. And we know that if you follow, inshallah, on time, inshallah.
Yes, sir, who are staying outside the campus or outside Malaysia, so they are facing trouble, I guess. So what would be the suggestion for them?
That one, you have to refer to the Deputy Dean Academic. Deputy Dean Academic can answer this question.
Okay.
Yeah,
sir,
you can email him.
Okay, sir. Sir, to improve design of experiment skill, like, do you have any suggestion, like we need to read this kind of books or any websites or something? Like, we want to be expert in design of experiment. We want to be expert. So, if you kindly share some links.
Yeah, I'm really appreciate the attendance of most students today. More than 60 students attend this session. This one very good. That means to show me that your seriousness about to have knowledge on this one. I'm going to add, there is one, what version of DOE do you recommend? I recommend the latest one. Design expert come from design expert number 10, version 10. Already there. It's a very good one. Because it's meant to use the whole interaction part. is there. I'm going to add, as I mentioned to your sister, I will send to the PGSA right now, complete one book about this design expert. If you really go through it, I guess it's for me more than enough. Give you a lot of information. If you go to YouTube right now, you'll find some, look at the area that you are in, mechanical or chemical or electrical. Go and deep, you'll find some. I know some scholar now, they put a lot of, especially for share file or share. Let me just find it for you. Share something I have here. Slide share. In slide share, you'll find so many good PowerPoint presentation about design of experiments, especially in the area that you are interested in, chemical or mechanical or electrical or biochemical, even biological or even agricultural side of you, huge information. Nowadays, scholars become very generous, especially of this COVID-19. They put everything over there. So really you can enjoy your time. And as I mentioned my student, now you're very lucky, everything is there and for free. And you have your telephone in your hand. Rather than to listen to music, listen to download one class about experimental design, listening to it more than 1-2 times, you'll be good enough. Even during Viva, you'll not give a chance to anyone. You know exactly what you're writing. Here the PGSA asks you please collect your certificate and fill the feedback from the e-certificate here, https://rb.gab0j. So please you find it at the chat. Any question?
Right. No, sir. Thank you so much, sir. Well, like on behalf of PGSA, I am Vice President. My name is Mahfouza Sultana, and I would like to, I'll be so happy if participants give the feedback from input so that we can serve there. And I'd like to hand over to our moderator to say something.
Yeah, thank you, brother and sister. I'm really honored to you to the PGSA. Send the link for the recorded material and the whole material that I promised to give it to you. I will send it to PGSA. Please consult with them. You'll find it. Thank you very well for your attention and for attendance. Yeah, Dr. Water, your voice not clear.
Terima kasih.
Okay, so thank you.
والله برو اتحفنا والله.
الله يبارك فيك يا احمد، الله يكرمك ان شاء الله.
يعطيك العافيه.
الله يبارك فيك.
وخلاص كيف
يعافيك يا احمد.
كيف غيرت زي ما الحمد لله تمام كانت والله ما شاء الله.
بارك الله فيك. بارك الله فيك.
Thank you. Welcome.
Thank you, Prof.
Thank you, Ahmed. Thank you, Ahmadu.
ما بذول خشية من الناس اللي شكله الوقت بدري شديد عندهم.
الوقت بدري عليهم جايين والله واسع، عشان كده انا كنت اصوره وارسلهم بس. تقريبا امبارح اتصل علي دكتور لبنى، ممكن احضر مع ناس. ها؟ كان
ممكن بدل ما بيحضرها. انا رسلت للناس
عليه قلت اجي. يا اخوي الناس هاي تعرفهم كويس، مشاكلهم براون. الله يعينهم.
الفيهم وكفيهم. الحمد لله. ماشي بعد يلا السلام عليكم مع السلامة.
السلام عليكم ورحمة الله وبركاته.
شيخ خالد.
Thank you for your invites.
Thank you, brother.
I'm Rimas, PGSA President. I really appreciate your time, and I hope your support will be continuing with PGSA in future also, inshallah. And thank you for all the participants. Assalamu alaikum wa rahmatullahi wa barakatuh.
Allah bless you on your attendance and bless each and everyone in this attendance today. Jazakumullah khair.
Thank you so much, Prof.
Thank you very much, brother. Thank you. Thank you.